So yeah, test runners take some code that someone's written, run them against some tests, and give some sort of output. And we'll be using that in two ways. We'll be using it as a feedback loop for when you're trying to solve the programs in the browser. But we'll also be using it to verify code that people upload via the CLI. In V3, for concept exercises, you won't be blocked by mentors anymore. So there won't be mentoring on concept exercises, at least not automatic, at least not human mentoring. There will be lots of automated feedback, which we'll come to. But the way that you will be able to progress through concept exercises is through passing the tests. So that becomes really important for both the CLI and for the in-browser coding, that we can reliably run the tests and get results, which is why test runners are a prerequisite for tracks being able to have learning mode on V3. The test runners themselves are surprisingly devilishly hard to write. Everyone has thought, oh, I'll just write a test run, it'll take 10 minutes. And then like 10 days of agony later with weird edge cases, we end up with some working things. I think we pretty much all found that. But we have test runners in at least 10 languages now. I mean, we might be even getting up to 20 languages, which is awesome. So I think most people understand the concepts of test runners. There's a spec that Eric's posted, a link to on the side, which is been pretty well honed now by people complaining that it was missing stuff and then helpfully adding it. So I think that's good enough for most people to work off. So just starting.
So just to be clear, the basic version of the test runner isn't that hard. So you can get the basic version working relatively easy most of the time. It's just that we have some additional features, like, for example, capturing standard output that the user is trying to use to debug. Those are harder. But you can just create a test runner without those features and add them later, as long as they're running the tests and then outputting the correct format. We're sort of happy already. So.
Yeah,
and you should also mind the no network limitation, which can be really difficult if you allow your users to pull in repositories or features or whatever from the internet, because that won't work. For example, for JavaScript and TypeScript, we cannot actually run the current exercise package, but we have to basically hope that the package we're running is going to work.
Yeah, so one of the limitations of all of these things is that they don't have network when they run. I hope the reasons for that are logical, that we don't want people being able to arbitrarily access network via our servers, especially because they have my credit card on them. So that could get bad quickly. So you have network when the Docker machine that your test runner is bundled in builds. So you can install dependencies then, and then it's a matter of ensuring that users are only using dependencies that are previously installed on the machines. So where possible, don't use third-party dependencies. Where not possible, and JavaScript is one of those ecosystems where there's a lot of packages that are relied on. For example, I think Rust is probably another one. It's about making sure that the right things are on the machines, and then we somehow give very clear instructions to the users about what they can and can't use. Eric's put a link to the
so I've put in a link. That's a Docker file for the F# test runner. So it's a .NET system, and what I do is that I pre-download some of the most used packages, and then I copy those into the actual Docker image that's being produced, so that it doesn't have to use online functionality to be able to access the packages. It doesn't actually totally work yet, but the idea is good.
Nice.
Right.
Indeed.
So DJ does the same.
Yeah, and that one works.
So this is less of an issue than you might think, because we in general don't want many external dependencies, and if possible none, for our exercises. So most of the exercises would just use the standard library, and you don't need any additional libraries. And you can't even install extra dependencies if you're using the browser. So
yeah, that's all good. Thanks, guys. Ninja asked the question about test runners of whether the spec is changing for V3. And what he means by that is the spec between the research exercises which we've already built and the V3 stuff. He specifically says the example solutions that are placed in meta, which differ from our previous Alexa standard of them being placed in the exercises root folder. For now, we're just working to get everything working as it works in research. And this is a general thing that if you haven't worked on the research exercises, you might not be aware of, but for the research exercises, every exercise has its own config.json file. One of the things in that config.json file is that for every test in your test runner, there is a human-friendly description of the code that's running and a name for that. And this is something that everyone building the exercises hated, and then once they used the research site, understood why it was valuable and useful and good. We've not yet formalized that into a standard for V3, simply because it's still a bit sucky. And I want to try and come up with a bit of a better solution if we can before we sort of mandate that everyone needs to start writing these config.jsons. So it's something to do on our lists, but it's not something that's urgent at the moment. So writing your test runners to conform to the research site is the best way to go at the moment. DJ points out that he still hates it, but it still works. But it's something that, you know, maybe DJ, you'd like to open an issue for, and you know, we can brainstorm if we can come up with a better solution that doesn't lose functionality.
Eric and I probably just wanted to do for a lot of the tracks, you can automatically generate these files based on the test files. So as soon as we have some tooling that does that, and we can do it per track, then basically it's not an issue anymore. It could even run on commit or whatever. So
yeah, I agree. So that's one question I've got about test runners. Does anyone else have any questions they would like to ask about test runners at this stage before we move on to the more complex representers and analyzers? Excellent. I shall talk more. So then we have representers and analyzers. So let me recap about the differences and about where they run. So one of the key principles of V3, as I said earlier, is that we won't have people mentoring concept exercises. So mentoring becomes a really, really big part of the practice exercise side of things, and we're going to be making it an even bigger part of Exercism, but it won't be on these concept exercises. So the concepts, and the reason for that fundamentally is that we want people to be able to just go and work their way through these exercises without having to wait somewhere between 6 hours and 6 years for a mentor. Because even if it's 6 hours, or even in Ruby sometimes, I don't know about other tracks, but we hit like 15-minute response times, which is great, but it can still be enough that actually you just can't get any flow of getting into a learning mode and learning. So for concept exercises, we're removing this barrier altogether. And we'll be giving feedback in two ways, through analyzers and through representers. And while we discuss them in terms of being analyzers or representers, it's more helpful to think of them as sort of the more human side of what we're doing rather than the technology that powers them. So the concept of representers is that most solutions to an exercise that are posted or that are uploaded, we've already seen before. There are a huge amount of unique solutions to any given exercise, like a surprisingly large amount, like TUFA in any language, 350, 400 of the last 500 solutions will be unique. I tell people this and they don't believe it until they see the data. Like, can you write 400 different solutions to TUFA in Ruby or JavaScript or Python? And yes, you can, and they will be every time. But there does seem to be a cap for most exercises at a point where we don't see that many new solutions. This holds true for smaller exercises like the TUFAs of this world. That breaks down when we get to things like Bob, which is got so many different permutations it becomes impossible really for two people to have publish the same thing. So one of the things we're doing in designing concept exercises for V3 is making sure that the amount of potential solutions that someone can post that passes the tests are going to be realistically reasonably small. And we're doing that by having very focused exercises. So the side effect of that is that we know there are probably only going to be I say only, but there's probably only going to be 300, 400 different possible permutations to that exercise. Now, what representers allow us to do is actually reduce that number a lot more. So by taking a solution and determining what we're calling a representation of it, with certain things normalized within it, we reduce that space a lot. So, for example, if we remove variable names from the solutions, so we normalize all the variable names, we see that the amount of unique solutions pretty much halves. If you then look at other things that are functionally the same,
White space.
Yeah, white space is a good example, whether you put the brackets on the same line or a different line, whether you use a ternary operator instead of an if statement. You can choose as a maintainer how far you take this and more you put in guidelines, but you can normalize those quite varied solutions down to a much smaller bundle of solutions. At which stage, say we have, I don't know, 50 to 100 unique solutions for TUFA, somebody can go through and provide a piece of feedback on each of those 50 to 100 solutions. And then in future, every time someone posts that same solution or a solution that comes up with the same representation, we can give that same piece of feedback. So by a mentor mentoring 50 solutions, we suddenly mentor every solution to that exercise forevermore. And we can give these back instantly, 5-10 seconds, as long as it takes to take the tests it takes to generate representation and give this feedback. So the concept of this representation is that effectively we crowdsource mentoring on a set of these exemplar solutions or normalized solutions, and then can immediately give that same feedback. So this is a really powerful mechanism of getting mentors to do something once, and then that bit of mentoring be reused many, many, many times. So there's lots of things that we're building into that. Obviously, there's the technology of building the representations, which is what we're talking about more here. We are also having the element of giving feedback and building a nice UI around that and understanding who can write that feedback, because obviously that feedback is pretty important as it's going to go to hundreds of students potentially over time, thousands of students, and editing and moderating the feedback loop as well. But fundamentally, the system itself is quite straightforward. Someone's asking a question, Victor's asking a question on the side here, how this works with iteration, or is it only going to be one iteration? So the idea would be that somebody, the nomenclature will probably change slightly, but somebody effectively runs the tests, gets to a point where they've got the test passing, then sort of hit a button that says submit for analysis. It will be less nerdy than that probably, but some feedback will then automatically be given by the representer if applicable. That feedback will be trying to guide someone to a perfect solution, and that feedback will have the ability to block progression. So the rule will be if the tests pass and there is either no feedback from a representer or the representer approves the solution, then you can move on. But the representer still has the ability to block a solution. So in either the scenario where it approves and the student wants to, where it approves and the student wants to improve it, or in the situation where it blocks it, the student can then refactor their code, submit more iterations, get more feedback. But the way the representation, the feedback on the representations are given is that we're going to be trying to get people to one perfect solution. And that for each of these concept exercises, we presume that there is an ideal perfect solution because they've been written with that in mind, which is very different from the practice exercises where people can fight to the death over this even more than they can fight to the death over whether runtime has a space or a hyphen in it or not, as we've seen for the last few days. Is your pitch on here? Yeah, he is. So Katrina agrees with your pitch. That's a secret thing that I don't know if I'm supposed to say, but that's the canonical answer to the runtime discussion. I don't even know what your pitch says because it's been such a ridiculous discussion. But that's the general idea of a representer. So take a solution, normalize a load of stuff about it, put it in a database, put some feedback next to that database. Woohoo, your pitch says yay. Put some feedback next to that in the database. Whenever we see that representation again, we automatically give the same feedback. Questions?
Yeah, so the representer is actually, I found it very fun to write. It depends a little bit on if your language has great support for parsing your source code into an AST and working with an AST. But if it doesn't, even then you can do lots of things. The most basic representation would be taking source code, normalizing white space, and just outputting the normalized source code. That's by far the most basic one. You can do lots of iterations and normalizations. I've posted some links there. There's also a document called normalization.md, and it has some examples, and some of them Jeremy already mentioned, about normalizing variable names. You can also think of reordering the method names, for example. Shouldn't matter in most languages, unless it's F#, for example. But it's a fun thing to write, and it's actually not that hard. It sounds really, really difficult, but I found it in practice to be relatively straightforward, compared to a test runner that sounds simple and is harder to get completely right.
Yeah, totally. I found it quite challenging in Mubi, just to get my head around various bits and bobs of it. So things like normalization of names is quite an interesting one. So anytime a name pops up, whether it's used in a variable or a class or anything, that then gets mapped out. So when the feedback is, so if we've got a solution that's like define foo as an example, as a method, we would take that foo out and replace it with a placeholder. And then the feedback that somebody gives goes against that placeholder. So they'd be, if they're discussing the first method, they would discuss placeholder 1. Then when somebody else submits their solution, we look at what they've called that method, and then we map that method name into the feedback. So the feedback feels personalized to the solution you've written, but it only has to be written for those placeholders. And so there's things like mapping files that the representers output as well to do this. And that bit got quite tricky, but it's like really interesting and tricky rather than unpleasant, tricky to write.
So the normalizing identifiers, I have that in C#, and I thought it would be very, very tricky, but it turned out it was actually quite easy. But that's also because the C# compiler has great support for parsing source code and working with syntax trees. But I know many languages do have good support for that. And well, you can take inspiration from the representatives that have already been built. So when I did an F# version, I looked at the C# version and just, well, changed it to a different language basically, and a different syntax format, but the basics are still the same. So once you get these familiar with other representatives, you can reuse information and algorithms they use. And, well, I found it very much fun. So if you wanted somebody to spar with, you can always hook up with me, and I'll be more than happy to talk to you about it.
Yeah, so there's a channel which we've got, which I think is automated analysis on Slack, and we talk about both representers and analyzers in there. I'm just gonna, just before DJ comes in, I'm just gonna answer this question on the side about when a new solution pops up that there's not a representation for, I think is the question. So yeah, in that situation, if there's not a representation for the solution and there's not an analysis for the solution, then we're just gonna approve it and let someone move on. Hello, Ellie, or Eli. Ellie or Eli?
It is Eli, thanks.
Eli. Hello, Eli.
But most people say Ellie, so.
Okay, that's all good. Welcome. Yeah, so in that situation, if there's not a representation analysis that we can do, then, and the test pass, we just let someone move on. If the feedback is given to that solution at a later date, or given to the representation at a later date, we will send that feedback back to the person. But it won't have affected whether they can have moved on or not. It will have already been approved by that stage. DJ, did you have a thing you wanted to say?
Yeah, so the question I do have is related to this, and that's representers and giving feedback on representation, of course, is really, really easy if you do a one-off. So, hey, here's the solution, give me some feedback. But what do we do, or is there anything planned for users who are constantly doing iterations and getting feedback based on the representation, but that feedback is not... Basically, let's say I'm doing the little twofer solution, and I fail to to correctly or to idiomatically use some default parameter, whatever that is in your language. And the first time I submit that based on the representation, I'll get some feedback. Hey, did you know you can do default values? And then I do another iteration that doesn't solve it. Am I going to get feedback that is based on both, or that is just based as if that was the first iteration I sent?
I think you'll just get it as if it's the first iteration you sent. I mean, the other thing there is the infinite loop of you just keep on getting the same representation over and over again. So, I mean, I think you and I talked about this really early, DJ, about do we do we pass in some other information like what the thing they got was, what the feedback they got last time was. That could just be internally database IDs of the feedback they were given last time, so we can ensure that we don't give the same feedback again. I think we can do that sort of thing at a website level. So the website is guarding against giving the same feedback twice, as opposed to trying to do it at a representer level where there's some intelligence in the actual language specific tooling.
Yeah, I would like the website to handle that.
Yeah, so I mean, the only, and this is very different from the analyzer. So the only thing we're expecting the tooling of representers to do is to create this representation. We're not expecting them to map the representation to feedback. We're not expecting them to work out there's no intelligence in this. Here is some code, give me a language specific AST'd out representation of this thing that's consistent, which is very different to the analyzer, where we have a lot more of the feedback built into that, which we'll talk about in a minute. So I think all of that intelligence handling needs to be at the website level, which does then mean that there is no intelligence about if somebody's gone from A to B to C, what's that feedback loop. I think we need to think about what happens if we would give the same piece of feedback twice. And there's a whole question here as well about, if there are two solutions that are very similar but have different representations, which will definitely happen, is there an easy way that we can point them both to the same piece of feedback internally? Or, because what we don't want is two very similar solutions, two different mentors coming along writing two different pieces of feedback, and then people just getting repeated feedback that's saying the same thing but slightly differently written each time. So there's a whole load of product questions in there that we haven't got answers to yet, but which we will have by the time we launch. And they're good things we need to discuss. I think technologically, all we need to do is get representers that take code to a normalized ASTs. And that's quite a well-formed, well-specified job. Is that enough for you, DJ, for this bit?
Yeah, that's good.
Thanks. Does anyone else have any questions about representers, or should we move on to analyzers?
Yeah, in design.md, there's a section for representers. Mm-hmm. What might be in there? What for somebody who doesn't know how to implement, is not on that side, what kind of thing might be in there?
So I think initially it will all be empty. There will nothing be there. But I could imagine that for some exercises, you would not be interested if somebody's using an if statement or a ternary expression or a switch or whatever. But in general, there might be other exercises that would have liked to include the if or the ternary in their representation. So it would be like making an exception for a single exercise where I don't really care about this bit and we can strip it out. That might make sense, but I would say this is more something that we could do very much in the future because it doesn't really make sense to start tweaking those things already. But if we find that, for example, for the twofer, over half of people is doing something that doesn't really matter, and we can rewrite it to the other half without losing any information that's important for us to comment on, then we could implement that in a exercise-specific representation. But I think for now we should not do it. I'm just included it for the future, but it will be empty, I guess, for like virtually every single exercise that we're doing now.
Yes, I agree with that. So I'd say, just to say that in a slightly different way, the way I see it is almost the granularity of normalization per exercise is sort of the mental model I have of that. So, you know, if we don't care about how someone's using a conditional, we might normalize every type of switch, if ternary, to the same normalization pattern, which means that the same feedback can then be given to a whole load of solutions rather than that. So it might be that we write representers that that have a whole load of flags. So they might have a conditionals flag that we can turn on or off. And if that conditionals flag's on, then we just merge all conditionals into the same normalized solution. But I think we need to get enough of a widespread of representers and then experiment a little bit with that, like Eric says, to understand the practicalities of how that works. But I guess if there are any things that are obvious to you when you're making those exercises, like if you're writing it and thinking this exercise really isn't about conditionals, we really don't want to care about conditionals in this, then making a note of that in that representer might inform us later down the line that that's something we should consider. Does that make sense, Mike?
Well, you talk about if something makes sense to you. If you take a naive contributor, somebody who's contributing an exercise, maybe they're only one. What kind of guidance is there for them? I mean, I'm kind of with the program, and I barely can understand it. Is this something where we could reasonably say, don't worry about this, leave this, it'll be covered by review points, or what kind of steer can we give to people?
Yeah, I think something like that could work indeed. So you're saying that why do we have it there if we're expecting people not to care?
No, well, that's a kind of negative way of.
Oh no, I don't mean it in a negative way. Just like it's there, but we don't expect people to do much with it yet.
Yeah,
so yeah.
I mean, you're faced with this section. You think your goal is to fill everything in. It would be nice to know, maybe this is something you're not going to be able to fill in. That would be good to know.
Yeah, I agree.
Probably true for the analyzer as well.
Yeah, probably. Yeah.
Oh, yes, to exponentially, sure, for sure.
Yeah. So one of the things I'm planning on doing in the next few days as well is just doing a guide to the concept exercise, to that contributing file that almost talks someone through it as a video. So the first time someone contributes, they can just watch a video on, not about how to actually fork an exercise or think about an exercise, but the structure of the exercise. And I think things like this, Mike, are really helpful in, what do we care about and what do we not care about for somebody that's hitting this stuff for the first time.
Yeah, and for people that might not have noticed, Mike has done a pull request on the C# track, and he went there in blank. So it was his first exercise. So he made a list of all the things that he encountered that were not really intuitive, and that we have to explain better. So it's a great list. It's in an issue somewhere on the V3 website. You should have a look. And we're trying to get all the information that wasn't clear to make it clear. So this is an excellent resource, and I think we'll be improving on that soon.
Yeah, I couldn't agree more. That was really helpful, Mike. Thank you. And thanks for bringing it up, Eric. Has anyone got any other questions about representations?
So a quick note on that. So would we then not have the representer and analyzer section in our concept exercise issue template?
Yeah, so I think we probably want it in there, but maybe just having a comment in there that says, feel free to leave this blank if you don't, if you're not working on a representer or not a fay with this bit, might make sense.
I see. So the template itself is kind of the long-term, everything that will need to be part of a fully completed concept exercise, and we want to keep in there. Because I guess I'm just asking, because as I've created a few for the Rust track, I often just say not applicable, partly because I didn't understand it, but it sounds like I was right, because we're not just getting to that yet.
Yeah, exactly. I think, it doesn't matter yet. And I think we've gone through thinking, like we, probably being me and Eric, when we drew this out first, thinking what of all the things that we would put in there. But obviously, we're living and breathing the big picture of representatives and analyzers. I hadn't thought about the fact that this probably feels a bit esoteric and a bit overwhelming for people hitting that the first time. So yeah, I think definitely not applicable is a perfectly good thing. And I think maybe in that issue template, as in the when you go to new issue button, I think there's a thing there, you can put it in there saying, feel free just to leave this out for now. I think that's a really sensible thing. Someone said, can someone please post a link to the PR from Mike?
I'm working on it.
Awesome. Thanks, Eric.
That's
nice. Oh, Bethany G, nearly. Eric just beat you. Any more questions about representatives? Cool. Let's talk about analyzers. So analyzers are super cool. Analyzers say, take someone's solution and work out what feedback to give. So whereas representatives are just doing the sort of, for lack of a better word, like dumb thing of just like passing code into AST, analyzers are like trying to be intelligent. I use that very in quotes. So they are trying to find the right feedback to give a solution to move someone forward. So there's an awful lot more complexity and thought that needs to go into an analyzer, but they actually don't have to be that hard. So the reason they don't have to be that hard is, for most exercises, there are a very small amount of things that you commonly see people make as the biggest mistake. So going back to the TOEFL example, just because I think it's an exercise that most people will be familiar with, although I think it's really low down the chain in Rust, so Eli, you might not be as familiar with it, but it's a really easy exercise. But it's the basic thing for most languages is whether you correctly use the default parameter or not. If you set the default parameter to be you, then probably you're going to have the exercise 99% there. If you don't, then there's probably some sort of nonsense you've written below to try and get around it. So all an analyzer needs to do is look for whether someone set the default parameter or not. And then it can just give a piece of feedback saying, set the default parameter. And that one piece of feedback then actually gets most people to start to putting a second iteration that's like spot on. And so the analyzer will go, it will take the code, it will break it down into its abstract syntax tree. If you're not familiar with ASTs or abstract syntax trees, it's a real tongue twister. It's just a slightly different way of looking at code. That's as much as you need to worry about for now. It's not hard. But you can just find that one line in the abstract syntax tree and then say, have they used the correct default parameter or not? And then if they have, then you say, okay, there's probably something else wrong with the code. Let's not worry about this for now. And you can just say, I don't know anything, sorry. If they haven't used the correct default parameter, you can say, aha, here's a piece of feedback. And then boom, 50% of people that submit TOEFL are getting a really intelligent piece of feedback within 5 seconds that unblocks them and helps them. So that's like the magic of analyzers. And so for quite a few tracks now, every single TOEFL solution that gets posted has automatic analysis that covers pretty much every permutation. We don't necessarily show them all to users, but in a good handful of tracks, we now can 100% automatically feedback on TOEFL. And some tracks like JavaScript, Go, probably C# got a couple as well, that's extended to like lots of other exercises as well, not just TOEFL. So the secret to making analyzers is to find the one big thing where people keep getting unstuck, or the one big change that you could make, and look for that one thing and give some feedback. And then find the second and third and fourth and fifth things. And by the time you've done that, you probably cover 90–95% of cases, which then means we've reduced these 400 solutions that need representers. 350 of them we can automatically analyze by looking for like 4 or 5 things and give feedback to, which then means only 30 or 40 solutions at the end of it, #maths, actually need to get some sort of representation written for them. So we've massively reduced the amount of work that needs to happen for people in giving feedback just by picking off one or two of these low-hanging fruits. So representers have basically the same, analyzers have basically the same interface as representers. They take some code, they take the slug of the solution, and then they do something and give back a JSON file. That's the basic idea. Does anyone have any questions about it at this stage? There's like a million directions I could go into more depth about, but I don't know if there are bits that are unclear or clear, or if all of that was just gobbledygook to everyone.
So that means the analyzer basically takes the solution and gives a feedback that we the maintainers wrote, right?
Mm-hmm. Yeah.
So we must. It's something that evolves over time.
Yeah. So at the moment, and this will probably change. At the moment, the feedback itself, as in the written language that someone sees, is in the website copy repository. And what the analyzer does is it returns the slug of the piece of feedback that's going to be sent back, and any variables that need to be interpolated into that. So DJ or Eric, maybe you could just link to like a sample website copy with a couple of interpolated variables into the right hand side. But it might be for TUFA, we might have something like we would return something which is like feedback default parameter, and then we would have a JSON hash which would be something like user parameter and then nil. And then we would interpolate that saying, rather than using a default parameter of nil, use a default parameter of you. So again, the feedback feels really personalized to that person because we've pulled bits of the language they've used in their code out and interpolated it into a piece of generic feedback. But the feedback can still actually be maintained separately from the analyzer itself. So we don't end up with natural language built into the middle of this code base that makes it quite impenetrable. And it means that mentors can be the ones that are actually writing the feedback and refining that and making sure it's done empathetically. And the maintainers don't have to worry about any of that. They can just be writing the more hardcore code over here. So the link that Eric's just shared on the side.
Yeah, so that's a C# analysis being done on TUFA. And this student used a default value, which is good, but it used a default value of an empty string. So what I want is the parameter name. So they could change that possibly. And the actual default value. So those are the parameters that you can see in the analysis JSON that is shown on the analysis page. And if you go to the second link, you see that the actual message uses placeholders for those two parameters. So we basically substitute the values that we found in the analysis with the placeholders. Or reverse. Yeah.
Does that make sense to everyone? Can people see those two links? So this whole section is quite interesting to look through. DJ posted just above the link where you can browse these, but they all look like this. So you can see the track, the exercise. You can see that the analysis status on this one is disapproved. So we've said, we want to disapprove the solution because there's something wrong with it. And then these different comments that go back, which Eric's just explained. And then at the bottom, you can see the example solution. So if you go to the link that DJ put in the side, to the analyses link, you can explore these in whichever your language is and see different permutations. At the moment in V2, if the analyzer approves, then it automatically approves. And if the analyzer disapproves, then it gives that feedback to the maintainer, the code. We never actually send code directly, send disapproval messages directly back to the student. But that will be changing in V3.
Yeah, and approvals can be accompanied with one or more comments too. Mm-hmm. So, for example, there are valid solutions, but that might not just be optimal. So we can say, hey, this is good, you can continue, but you could have also done this if you would like to, so that you can get a little bit of extra feedback if you can improve your solution, but you don't have to do it in order to continue.
Thanks. Any other questions about analyzers at this stage?
So maybe to recap my understanding, analyzers and combined with representers are a way to automate this problem solving for how you match a learner with valuable feedback, practical valuable feedback.
Exactly. And both of them are trying to guide a student towards an optimal solution. That's the big thing.
And without waiting on a mentor.
Yeah, like so in the way that the student themselves is seeing it happen before their eyes versus
Yeah,
getting
precisely.
out because the mentor didn't respond for 3 weeks.
Yeah, very rapid feedback, so you can iterate it on it very quickly.
And the reason this works is because the V3 exercises have such small solution spaces. So there's only a small amount of reasonable solutions that can be given, which is why I keep on banging on and on about making V3 exercises small, because the whole thing falls apart the moment there's 1,000 different ways to solve one of these exercises. And it's the same reason that analyzers and representers won't work well for the practice exercises, and why those become really interesting in terms of real mentoring. And there is some stuff we can do there, but it's a lot harder.
Do you want to talk about the experiment we ran?
The research one, or?
No, the analyzer one, where we also give commentary for mentors as opposed to for students.
Do you want to talk about it?
Yeah, so basically, long story short, I was very early on doing a lot of analyzers for JavaScript. And at some point, we've noticed that mentors would just copy and paste whatever we would put in these snippets. But that a lot of the time you don't actually want to give away the answer or the actual answer or the actual reason why you analyze something. Like a lot of the times when I was doing a little bit more difficult exercises, for example, resistor color duo, which some of the tracks have, but others don't. You want to explain to the mentor what is not idiomatic, but you don't want to just forward that to the student because you're going to take away a lot of the fun that is to actually getting to that solution yourself. And of course, a lot of that we wanted to put into the mentor notes. But at some point, I realized that actually the analyzer would also be a very, how do you say, a very reasonable way to give some of this feedback to the students. So I just posted a solution. I think it's part of this analysis. And you'll actually see, if you click that, you actually see a disprove with comments, and you'll see both a blue block and a white block, where the blue block is for the mentor, and actually gave something that they could copy and paste, which they don't need to do. But in this case, where we're actually explaining why the analyzer is disapproving it without giving away that solution to the students. And especially if we're going to look at the practice exercises in V3, if you do want to support mentors here without writing very expensive mentor notes, you can, if we roll this out to all the other analyzers, do this for mentors as well. I've gotten really good feedback from some of our top mentors that is basically either, hey, these suggestions are great, but they're wrong, as in the one you make copyable is actually the one that I want to read, and the one that you give for the mentors is the one that I actually want to copy and paste. But in general, they were really happy that sometimes it will be just, hey, just copy this because it's fine. And then other times like, yeah, but I didn't understand why the analyzer disapproved this, but now I do. So especially if you find yourself with, hey, I want to explain more, this would be a way to do it.
And I think it's a really a really interesting thing to consider about practice exercises as well, because with the large problem space, one of the reasons that I'm so wary of using analyzers is because it's really easy to give the wrong feedback to a student. It's really easy for them to use a function a certain way and for us to pick up on that and think, oh, they're doing something wrong, but actually they're just being clever, or they're just doing something slightly different. And so one of the nice things here is being able to give mentors suggestions as to things that they might want to give to a student. And the mentor can then use their human intelligence to actually work out whether it's applicable or not. And that's a really, on some of these as well, I think, I didn't see if it was an example you just put, but, you know, we say this comment might be wrong. Like DJ even put that on some of them.
Yeah, so in a few times I'm doing, so this is actually happens, I think in gigasecond, which is the one where you take a date and you just add a gigasecond and you give back the new date or whatever the equivalent is in your language. Some of the analyzer I wrote was very experimental in the sense that I knew that I didn't guard for all the options, because in JavaScript there are literally, I think, 26 different ways to write a gigasecond idiomatically. So that is not including all the ways to write it incorrectly. And we're just talking about the number a gigasecond, not about the actual solution. So instead of trying to cover all the cases, I put in some heuristic that's like, hey, if you see this, it's probably this, but it might not be. So instead of giving this as feedback to the student, we wrote a little mentor note with the experiment that said, hey, this might be wrong, you can check it like this. And then most of the time it was right, but a few times it was actually wrong, which one of our mentors actually noticed. And then we iterate on top of it. So it also allows you to do some of your analysis and write them and deploy them without, you know, worrying about if it's 100% correct or not.
Go as well uses a like a probability matrix to understand what feedback to give. So it looks for certain things, and then based on whether certain things are there or not, it then sort of says there's enough evidence that I should probably give this feedback, which makes it, again, a lot less reliable, but it makes it a lot easier. I mean, it's still like 99% correct, but it makes it a lot easier just to look for lots of different heuristics and then give a probability of some feedback. And so for that sort of thing, I think that works really interestingly for practice exercises.
Yeah, I think one of the reasons Go did that as well is that they wanted to make sure that they don't overwhelm the student. So when they see that something structurally is incorrect, so it will just not be parsable, or it won't run the test, or they're using integers as opposed to strings or whatever, basically it's giving that feedback a very high value, and then it just bails out. But when there's a little nitpicks, you know, it's going to give more little nitpicks, because at that point, at that iteration, you're probably okay with receiving a lot of small edits. And that's how they try to solve it. Both Jeremy and I do something similar, but we just bail out early. So we search for the most important things. We look for the most important things first, and if we find them, we return that message and then just bail out. And then at some point we're like, okay, no, these are the nitpicks, and then, you know, just fix all of them, which is in line with what some mentors have been asking us in Mentor to Mentor, like, hey, should I give all my feedback at once, or should I try to pace it? And we say it depends, and these are ways you can do it, and there's no one right way. It's I think it's, you know, build it and learn from it and get feedback from both your mentors and your students.
I think with analyzers as well, they're really hard to build with teams of people. So like test runners and representers, they're like software where people can just PR to it and you can just be improving it. For analyzers, you have to get quite deep into your thinking of it and into like how you are framing a mental model of looking through exercises and reading through stuff. And so I think it is good for each track just to have one person that really wants to own that, one track that wants to own that analyzer and really build with it and run it and build like, this is the way this track is going to analyze exercises. And then at that stage, I think it's easier for other contributors to build analyzers for individual exercises. But I think you need to have someone that builds out a really good first set of things for this first. There's a link DJ just put in about how to write an analyzer that he wrote for TypeScript. We're going to do some videos on this as well over the next couple of weeks. Both Eric and DJ have suggested to me that they would like to chat about this, and I think we could get a nice little panel of us that have written analyzers to just share stories of pain and fun and joy along the way, which could be a quite useful thing to do. Eli.
Yeah, I just had to comment, DJ, when you were describing the 26 ways of the date in JavaScript, I heard a lot of Snickers, and I'm gonna say that was strongly typed Snickers from everyone. Not naming your language, but this is perhaps the only place where I can make that joke and receive a lot. So, but I mean, it sounds really helpful to also consider the mentor, the inverse of the relationship to the exercise. So the mentor's experience with it and conveying that information to the learner as something that's potentially analyzable. I think that sounds great because it's not the same and there's all these possible complications, but yeah, just kind of connecting the two. I think I see what you're saying too, Jeremy, with the open problem space of practice exercises, making it more difficult to provide direct, helpful feedback, because it seems like for those, the goal is to learn by doing, and also the journey being more of the thing, without getting too cheesy, but just kind of looking at it as there may not be entirely optimal ways of coming to a certain solution, but the iterative approach of finding that solution and getting most of the tests or all of the tests to pass is useful enough in that it's giving you more skill in the given language you're working in.
Yeah, 100%. I think that's a good synopsis. One of the things that we're really pushing on with the practice exercise as well is the idea of people learning from reading other people's code. So as well as all of this slightly more like hardcore analysis stuff, we're also just going to be providing really, we haven't quite decided how, they're either going to be wiki based or maybe like articles that people can write as to how they would approach something. So you could write an article on how you would approach Bob in Rust. And then when you finish doing Bob, you could then go and read that article and learn from an expert on how to do it. And then one thing we want to do as well is to automatically group different solutions based on heuristics that people have done, so that you can then browse different approaches that people take as well, quite algorithmically. So there's both, here's some blog posts or some articles or some wiki posts, however we do it, about this exercise, and here are some sort of groupings of solutions for you to go and learn from. So the idea is really that requesting a mentor will be a sort of final step in that process. After you've played around with it, read some other people's code, read an interesting article, then you want to discuss it with a human or specifically ask questions to a human about it. That's where that final step of mentoring becomes really interesting and valuable.
Yeah, so this is something that we're referring to as approaches. And the idea is indeed that you have an exercise and there might be multiple idiomatic ways, might not be 26 as in JavaScript, but there might be 3. So, and probably there are trade-offs with each. So one might be very concise, another might be very performant. So we could do articles on discussing what the different approaches are and what the benefits are of doing it one way or another way, and then people can pick that up themselves. That's also how I did it when I finished the V2 exercise. I would then look at what other people did and try to learn. We're trying to build into the system that is, well, something that we provide for you. So you don't have to randomly select 100 exercises and hope to find a really good solution, but you get some sort of expert knowledge, easily accessible.
Yeah, I mean, it's worth remembering that Katrina has like co-written a whole book on just 99 problems, 99 bottles of OOP, like, which is a book on just how to solve one exercise in different ways with different trade-offs. And that's just for one language, and that's now been translated into a dozen other programming languages. So with each exercise, like, I mean, I must have spent 30 hours iterating on food chain in Ruby, and I still fundamentally disagree with Katrina on the best solution to it. And like, and that's like, to me, is a massive part of the fun of Exercism, is those sort of nerdy, playful conversations where you just learn things and explore ideas. And I think that's a really joyful part of the practice exercises for me, that smart, well-considered people can, not to big myself up, can disagree about the optimal ways to write, solve one exercise. So I think the more we can build on that, the more fun practice exercises become. and it's a really nice contrast to concept exercises where it's like, this is the right way and we're going to get you there.
Yeah, like pedagogy versus exploration. Like,
exactly.
you have to have a certain amount of proficiency to be able to appreciate using and exploring. It sounds like too, for multi-paradigm languages, this terminology works really well for, say, a functional programming approach versus like an object-oriented or non-functional. Like, I could see that being really helpful as someone who's not like a full-on functional programmer, but I'm trying to understand more of how to use it in actual software. That sort of concrete example is incredibly valuable.
Yeah. So one of the reasons that we're working on F# as one of the exemplar languages is because you can write code either functionally or object-orientedly as like first-class citizens in F#. And so it means that it makes it really interesting for a lot of these sorts of things to think about the variation that you might get, how that works in terms of introducing concepts in the first place, and then also, the different approaches. It's also, just as a totally tangential note, but you just made me think of it, the research experiment, there's a link further up in the chat. The purpose of that is to look at how different developers with different backgrounds solve exercises that could be solved in different ways. So a lot of the exercises have been written so you could solve it functionally, you could solve it in an object-oriented manner, you could solve it in other manner. And then the researchers can go and look and compare people's backgrounds to how people solve things and make interesting researchers conclusions about that, which they can publish. But that's going to itself be quite an interesting way of looking at some of this, and then hopefully they can do some clever machine learning-y, science-y shizzle to give us some nice grouping algorithms that come out of that as well, that we can then apply to core exercism for this approaches when we get there. Does anyone else have any questions about analyzers? DJ just posted a timer, which I think is to point out that we're an hour into this. I'm happy to carry on talking for a bit, although my voice is definitely going after a day of meetings. But if anyone has any more questions, I'll happily answer them. One thing, while you're thinking of questions, Neemjaw posted me one about this, which was saying, since most tracks seem to be going for an AST approach to analysis, have there been any good resources found to teach how to perform good analysis to actually capture the intended cases? So I guess that's something maybe just to ask in the V3 track, and then people can post links to afterwards. I just, for Ruby, just explored and played a lot with messing around with ASTs. It helps that Katrina literally analyzes ASTs in Ruby for a living at GitHub. So that was useful in her giving me some pointers about good ways to go. But I think there's different strategies, and I think us doing a video specifically looking at the different strategies that we've used to do that would be both really interesting and helpful as well. So that's maybe something we should try and schedule for next week or so. There's another question on the side, which is the data or metadata about the code assignments going to be analyzed? Is the data or metadata about the code assignments? I'm not sure what you mean by assignments. Could you expand that question a little bit? While you do that, I'm going to answer your earlier question of, is the analyzer commentary generated or picked up from a set of predefined commentary given by human mentors? So yeah, the commentary lives in this website copy repo that's linked just above your question. We say which things from that repository we want to be displayed. So the actual responses are written in that repo and people can edit them. They're just markdown files. But choosing which commentary gets assigned happens in the actual analyzer. So is the data or metadata, are we having statistical analysis on the data or metadata about solutions? Yeah, so we're not doing that at the moment. Like, that's not part of analyzers or representers, but that is what the researchers are doing for the research experiment, is looking at all of the different solutions that people post, the different types of paradigms and things they use in there, and then performing statistical analysis on that to try and link the solutions that people post to their programming backgrounds, to try and understand how the languages you learn and the order that you learn them in. and the question is, can we be part of that research? Yes, you can definitely be part of that research. So yeah, it will be a public site. We're just waiting for sign off on that. So it will be research.exercism.io. It's there. You can start it now. It's public. We're just not promoting it. And if you would like to contribute exercises or test runners to that, if there aren't already exercise or test runners for your language, that would be awesome. I think Common Lisp has just finished their test runners and they're about to put 2 exercises in there. There's a research channel on Slack where you can ask questions about that. But yeah, from a usage point of view, we're going to be like pushing out an email to all of our users. So like a lot of hundreds of thousands of people in the next few weeks saying, please come and help with Exercism v3 and please come and take part in our research. So at that point, we're hoping to get a whole massive group of people both contributing, which is why we keep pushing for people to make these concept exercise issues so that there's lots of people that can come and help. Lots of things for them to do, sorry, when they come and help, and also to get people using that. So knobs is going to disappear. I think everyone's going to disappear. So let's say goodbye. So it's only been an hour. Thank you very much. And yeah, I'll catch up with you all soon. We'll do another one of these next Thursday. So I'll put a poll in to see what time is good for everyone.